This is Heliox, where evidence meets empathy. Independent, moderated, timely, deep, gentle, clinical, global, and community conversations about things that matter. Breathe easy, we go deep and lightly surface the big ideas. All right, ready to dive into some more research?
Absolutely. Always ready for a good deep dive.
Okay, so today we're looking at how COVID-19 might be messing with our hormones even long after the initial infection is gone.
Yeah, the long-term impacts of COVID, still so much to learn.
Right, and this is all about endocrine disruption.
Yeah.
And its connection to long COVID. I mean, it's a pretty complicated topic, but hopefully we can break it down and make sense of it. What do you think?
I think we can. This research is really kind of groundbreaking stuff. It really opens up a whole new dimension to understanding, what could be happening down the road for folks who have had COVID.
Yeah, so let's start big picture. I mean, why should we even care about hormones and long COVID?
Well, think about it. Hormones are like the body's messengers, right? They control everything. Growth, metabolism, mood, sleep.
Oh, yeah. Hormones are a big deal.
Huge, huge. If those messengers are scrambled, it can really throw a lot of things off balance.
Yeah, that's a good point. So we're not just talking about a cough that lingers for a few weeks or something. We're talking about potentially bigger, more long-term issues down the road.
Exactly. That this research is suggesting is that COVID-19, it might be triggering these hormonal imbalances that could actually contribute to a whole range of long-term health problems.
Oh, okay. That's kind of unsettling. So how does COVID actually mess with our hormones? I mean, what's the mechanism here?
So one of the key things they looked at in this research was cortisol. Cortisol is our primary stress hormone. And what they found was that in some COVID-19 patients, cortisol levels are elevated. And this is even when the hormone that typically triggers cortisol release, which is called ACTH, is at a normal level.
So it's like the body's stress response system is stuck in overdrive, even when there's no reason for it.
That is a perfect way to put it. It's like your body is constantly on high alert, even though the immediate threat is gone. The researchers are calling this pseudo-Cushing syndrome.
Pseudo-Cushing syndrome.
Yeah, because it resembles some of the symptoms of Cushing syndrome, but without that usual cause.
Okay, so why does that matter? I mean, pseudo-Cushing's in the context of long COVID. What are the implications of that?
Well, Cushing's syndrome, whether it's true Cushing's or this pseudo version, is linked to a bunch of health issues, high blood pressure, weight gain, muscle weakness, and even an increased risk of infections.
Oh, wow. Okay, so COVID might not directly cause those problems, but it could indirectly increase the risk.
Exactly, that's the concern.
By triggering this pseudo-Cushing state.
Right, exactly. It really kind of highlights the need to monitor patients for signs of this endocrine disruption, even after they've recovered from the initial infection. We have to look at the whole picture.
Yeah, okay, so elevated cortisol levels, that's definitely a red flag. But how does all of this tie back to the idea of endocrine resistance, where cells become less responsive to hormones?
That's where it gets really interesting. The researchers found that COVID, both mild and severe cases, it seems to really ramp up the activity of various growth factors and their receptors.
Growth factors. Okay, so those are usually involved in things like wound healing and stuff, right? What do they have to do with hormones?
That's the million-dollar question, right? Think of it like this. Imagine a cell as a bustling city with different departments.
Okay, all right, I'm picturing it.
Okay, so hormones are like messages from headquarters telling each department what to do.
All right, got it.
But now, imagine that all of a sudden, growth factor signaling goes into overdrive. It's like all of a sudden you have construction crews everywhere, building new roads, new structures, emergency vehicles racing around.
Wow, it's chaos.
It's total chaos.
Okay.
So with all that going on, those important messages from headquarters, those hormones, they can't get through.
The delivery routes are blocked. The communication lines are jammed.
Exactly. The departments are totally overwhelmed. As a result, those instructions from headquarters, those hormones, they're either delayed, misinterpreted, or completely ignored.
Wow, okay. That really makes sense. So basically, the increased growth factor signaling might be creating a sort of hormone resistance by disrupting the normal communication pathways within the cell.
Precisely. And that, just like endocrine resistance in the body, can have serious consequences for how the cell functions, for its overall health.
Yeah, okay. So we've got COVID possibly triggering this pseudo-Cushing state, elevated cortisol, and then at the same time, it's messing with growth factor signaling. which could be contributing to this whole endocrine resistance thing.
Yeah, a lot going on.
But what specifically is causing these shifts in cortisol and growth factor activity? Did they pinpoint any, culprits?
They did. They found a protein called GNS that was significantly upregulated in the COVID patient samples.
GNAS, okay. Remind me, what are upregulated proteins and why should I care about this one?
So an upregulated protein just means there's more of it present than usual. And GNAS is particularly interesting because it plays a crucial role in regulating hormone production. It's like a master switch for a lot of hormones, including cortisol.
Ah, so if there's too much GNS, it could be throwing off the whole hormone system.
Exactly. That's what they're thinking.
Okay, so we've got this potential villain, GNAs, messing things up. But how exactly is it interacting with the cortisol signaling pathway? That seems like a pretty complex process.
Oh, it is. It is a complex process. But the researchers, based on what they found, they proposed a few interesting possibilities. They suggested that GNAS might be interacting with cortisol signaling through other proteins, like angiotensin, CRE molecules, and propiomelanocortin, or PMOC for short.
Okay, let's break those down one by one because I'm already feeling a little lost. What's the deal with angiotensin?
So angiotensin is a hormone that's involved in regulating blood pressure and fluid balance. And it's also a key player in this hormonal pathway called the renin-angiotensin-aldosterone system, or RAAS. And that system is often dysregulated in COVID-19.
RAAS, right. That has something to do with the kidneys, if I remember correctly.
Yes, it involves the kidneys, the adrenal glands, and blood vessels. It helps to keep our blood pressure and electrolyte balance in check.
Okay, and so how does GNAS fit into this whole RAS picture?
Well, GNAS is known to bind to angiotensin. So the researchers think this interaction might be influencing cortisol signaling in COVID patients.
Okay, so by binding to angiotensin, GNAS might be indirectly affecting the RAAS pathway, which in turn could be impacting cortisol level.
Precisely, like a chain reaction,
All right, that's one pathway down. What about those CREB molecules? What are they and how are they involved?
So CIF stands for CAMP response element binding protein. It's a mouthful, I know. But basically, it's a transcription factor, and it plays a role in gene expression.
Okay, and in simple terms, what does a transcription factor do?
Think of it like a switch that turns genes on or off. So it controls which proteins are produced by a cell.
Ah, so it basically dictates which instructions the cell follows.
Exactly. And CREB is involved in a whole bunch of cellular processes, including hormone signaling.
And how does GNS play into this?
Well, GNS can actually activate a signaling pathway that leads to the production of a molecule called CAMP, and CAMP, in turn, activates CREB.
Oh, okay, so we've got GREF triggering CAMP production, which then flips the switch on CREB, potentially influencing cortisol signaling. It's complicated.
It is. It's a cascade of events, but each step is important.
All right, that's angiotensin and CREB. Now, what about that PMOC protein?
PMOC stands for propiomelanocortin. That's a mouthful, too. But it's basically a precursor protein that gets cleaved into several smaller peptides, including ACTH.
Wait a minute, ACTH, that's the hormone that typically triggers cortisol release, right?
You got it. So PMOC is like the mothership of ACTH.
Okay, and how does GNS tie into this whole PMOC-ACTH connection?
So the researchers believe that GNAS might be influencing either the production of PMOC or the way it's processed, which could then in turn affect ACTH levels and ultimately cortisol signaling.
Okay, so we've got these three potential pathways: GNAS interacting with angiotensin, GNAS messing with CREB, and GNAS influencing PMOC, and all of them could potentially be impacting cortisol signaling in COVID-19 patients.
That's what the research suggests.
Wow, this is incredibly complex. It really just highlights how interconnected our endocrine system is.
Oh, it's a symphony of interactions happening constantly.
Well, I think we've done a pretty good job of unpacking the role of GNS and its potential impact on cortisol signaling. But there's one more piece of the puzzle I want to explore before we move on, and that's this whole idea of growth factor signaling and endocrine resistance. Can we delve a little deeper into that?
Yeah, certainly. The research team actually looked at the activity of various growth factors and their receptors in both mild and severe COVID cases.
Okay.
And what they found is pretty interesting.
Okay, I'm all ears. What did they discover?
So, in mild COVID cases, they observed elevated activity of a growth factor receptor called EGFR and an enzyme called MMP9. MMP9 is responsible for breaking down the extracellular matrix. So that's essentially the scaffolding that supports our cells.
Okay, so if MMP9 is more active, it could be disrupting the structural integrity of that scaffolding.
Exactly.
And remember our city analogy.
Oh, yeah.
If MMP9 is like a demolition crew tearing down buildings and roads, it's much harder for those hormonal messages to get to where they need to go.
Exactly.
So in mild cases, it's like this increased activity of EGFR and MMP9 is creating roadblocks and detours, preventing hormones from getting where they need to go.
That's a good way to think about it.
But what about severe COVID cases? Does the same thing happen?
Not exactly. In severe cases, they found that a different growth factor receptor was more active. This one is called the IGF-1 receptor. They also saw enhanced NOTCH signaling. NOTCH signaling is a pathway involved in things like cell fate decisions.
Okay, so instead of EGFR and MMP9 taking center stage in severe cases, it's IGF-1 and NOTCH calling the shots.
Right.
What are the implications of that shift?
Well, it suggests that there might be different mechanisms at play driving endocrine resistance in mild versus severe COVID. And along with those shifts in IGF-1 and NOTCH activity, they also observed changes in the levels of proteins that are involved in things like cell survival, growth, and stress response. So it gets really complex.
It's a much more complex picture in severe cases with multiple pathways potentially contributing to endocrine resistance.
Exactly.
This is a lot to take in, but I'm starting to see how this research it's connecting the dots between COVID-19, growth factor signaling, and this whole idea of endocrine resistance.
It's all connected.
But before we move on, I want to make sure I fully understand the role of MMP9. You mentioned earlier that it breaks down the extracellular matrix, but why is that so important in this context? What makes MMP9 stand out?
That's a great question. MMP9 isn't just some random enzyme hanging out. It plays a very crucial role in a variety of processes: tissue remodeling, wound healing, inflammation.
So it's like a construction worker that can both build and demolish structures.
Exactly. Good analogy. In normal circumstances, MMP9 is a good guy helping to maintain tissue health. But when it's overactive, it can contribute to a variety of problems, including endocrine dysregulation.
And in the context of COVID-19, the researchers are suggesting that MMP9 might be contributing to endocrine resistance by, disrupting the extracellular matrix like we were talking about.
Exactly. Right.
Okay, yeah, that's definitely going to disrupt communication and make it harder for those hormonal messages to get through. But you said MMP9 isn't always a bad guy. So in the context of COVID-19, could its increased activity also be beneficial in some ways?
It's possible. MMP9 is involved in wound healing and tissue regeneration. So it's conceivable that its upregulation in COVID-19 could be a double-edged sword, both contributing to endocrine resistance and promoting healing at the same time.
That's a really interesting point. So it's not necessarily all doom and gloom. There might be some positive aspects to these changes as well. This research is really making me rethink my understanding of COVID-19. I used to think of it as primarily a respiratory illness, but now I see that it can have these far-reaching effects on multiple systems in the body, including the endocrine system.
That's the power of research. It helps us, see the bigger picture.
Speaking of challenging assumptions, this study really makes you wonder about the potential long-term consequences of even mild cases of COVID-19.
Absolutely. We tend to focus on the severe cases, but even mild cases can trigger these underlying changes in growth factor signaling and endocrine function.
So just because someone had a mild case doesn't mean they're completely in the clear?
Exactly. Long COVID is real, and we're only beginning to scratch the surface of it, I think.
This is all a bit overwhelming, to be honest.
I understand. It's a lot to process. But the more we learn, the better we'll be able to manage it,
That's true. That's true. Well, I think we've covered the key points of this research article in pretty good detail.
I think so, too.
But before we wrap up this deep dive, I want to circle back to something we touched on earlier, and that's the concept of pseudo-Cushing syndrome.
Oh, good point. Definitely worth revisiting.
So as we discussed, pseudo-Cushing syndrome is a condition that mimics some of the symptoms of Cushing's syndrome, but without that typical underlying cause.
Right.
And the researchers are suggesting that COVID-19 might be triggering this pseudo-Cushing syndrome in some patients.
Yes.
They found that some COVID-19 patients had elevated cortisol levels, even when ACTH, which is the hormone that normally triggers cortisol release, was at a normal level.
Exactly.
So it's like the body is producing too much cortisol, but it's not getting the usual signal to do so.
Right. It's a bit of a mystery, isn't it?
It is. It is. But what could that something else be? The research mentioned calcium dysregulation and that overactivity of the GNAS protein as possible culprits. Can we unpack those a little more?
Yeah, sure. Let's start with the calcium dysregulation. Calcium plays a super important role in a variety of cellular processes, including hormone signaling.
Okay, so calcium is important for hormones to function properly.
Right, exactly. And so when calcium levels are off, it can disrupt the normal functioning of hormone-producing cells, like the adrenal glands, which produce cortisol.
So if calcium is out of whack, it can mess with cortisol production.
That's the idea.
Makes sense. Now, what about the GNAS protein? How might its overactivity be contributing to pseudo-Cushing syndrome?
Well, remember, GNAS acts like a switch, turning on or off the production of various hormones, including cortisol.
Right, right. So if GNAS is stuck in the on position, it could lead to an overproduction of cortisol.
Exactly. And the researchers found that GNAS was significantly upregulated in those COVID-19 patient samples.
Okay, so both calcium dysregulation and this overactivity of GNAS could be contributing to this pseudo-Cushing's state. This is all really fascinating, but it also raises some concerns.
Like what?
Well, if COVID is triggering a condition that mimics Cushing syndrome, what are the long-term health implications?
Yeah, that's a big question. And the researchers acknowledged that in their study. Cushing syndrome, whether it's true or pseudo, it's associated with a number of health problems, as we mentioned before.
Right. Right. We talked about high blood pressure, weight gain, increased risk of infections.
Right.
So even if COVID doesn't directly cause those problems, it could indirectly increase the risk by triggering the pseudo-Cushing syndrome.
That's right. And it highlights the need for healthcare providers to monitor patients for signs of endocrine dysregulation, even after they've recovered from the initial infection.
This is all starting to paint a rather alarming picture of the potential long-term health effects of COVID-19.
I hear you, but it's important to remember that we're still early in our understanding of this virus and its long-term impact.
That's true. More research is definitely needed.
Absolutely.
Yeah.
More research is needed to confirm these findings and determine the true extent of the risk.
Well, I hope that research happens sooner rather than later.
Me too. Me too. The more we know, the better.
Well, this whole conversation has been incredibly informative, but it's also left me feeling a bit uneasy, to be honest.
It's understandable. It's natural to feel concerned when you learn about potential health risks.
But I also appreciate the fact that we're having this conversation.
Me too. Knowledge is power. And the more we learn about COVID-19 and its long-term effects, the better equipped we'll be to manage it effectively.
Well, I think we've covered the key points of this research article in pretty good detail.
I agree. We've explored the potential link between COVID-19 and endocrine dysregulation. We delved into the possible role of growth factor signaling, and even zoomed in on the intriguing role of MMP9.
We've certainly covered a lot of ground.
We have.
But there's one last aspect of this research I want to touch on before we wrap up this part of our deep dive, and that's the technology that the researchers used.
Oh yeah, good point. This study utilized a technique called plasma proteomics.
Plasma proteomics. That sounds pretty high tech. Can you explain what that is and why it's relevant to this research?
Sure. Plasma proteomics is a cutting-edge technology that lets scientists analyze thousands of proteins in the blood, all at the same time.
Thousands. Wow, that's amazing. So they're basically getting this snapshot of what's happening at the protein level in the blood.
Exactly. And by comparing the protein profiles of COVID-19 patients to those of healthy individuals, they can identify proteins that are dysregulated in the disease.
And that's how they pinpointed those key players we've been discussing, like GNAS and MMP9.
Right. Plasma proteomics is a really powerful tool for understanding those molecular mechanisms underlying diseases, like COVID.
This is truly groundbreaking stuff. It really makes you realize just how far science has come in terms of understanding, all the complexities of the human body.
Oh yeah, for sure. It's an exciting time to be in research.
It is. It is. But before we get too carried away, I think it's important to remember that this is just one study.
Right.
More research is needed to confirm these findings.
I agree. I completely agree. While this research is incredibly valuable, it's really important to approach these findings with, a healthy dose of skepticism.
Yeah.
We need more studies, especially larger studies with more diverse patient groups, to validate these results and to determine their broader implications.
Right. Science is a process.
It is.
It's important to be cautious about drawing, definitive conclusions from a single study.
I agree.
Well, I think this is a good place to pause for now. We've covered a lot of ground in this first part of our deep dive, exploring the potential link between COVID-19 and endocrine dysregulation. We've delved into the intricate mechanisms of how this disruption might be happening, from the role of cortisol and growth factor signaling to the activities of these proteins like GNAS and MMP9. And we've even touched on the technology of plasma proteomics that made all of this research possible. Join us for part 2, where we'll continue our exploration of this topic. We'll delve deeper into the study's limitations, the need for further research, and the broader implications of these findings. Until then, keep those brains buzzing, and we'll catch you in the next part of our deep dive.
Thank you to our community, which now spans 59 countries within 394 cities in 15 languages, with auto-translated captions on YouTube and our English closed captions on all providers. Such a wide range of ages, mostly 18 and older. Thank you to those who have subscribed or followed on your podcast provider in Substack. You are widely outnumbered by those that have not yet subscribed. It makes a difference to independent producers like Hijacked. Please consider following, subscribing, and liking. Start a discussion on the episode content. Listen to the end for the Substack address. Back to Hijacked, where evidence meets empathy.
Find and follow us on YouTube, Facebook, Blue Sky, Substack, and your favorite podcast provider, including Apple Podcasts and Spotify. Join like-minded, curious folks broadly interested in exploring emerging pivotal science from a human perspective. Start or join a discussion about the episode's topic. Invite your friends to join the conversation, particularly if they are authors of similar papers or connect from another perspective. Back to Hijacked, where evidence meets empathy.
Sounds good. Picking up where we left off, I think it's important to highlight that the researchers were very upfront about the limitations of their study.
Right. Every study has its limitations, and it's crucial to acknowledge those so we can, accurately interpret the findings. So what were some of the limitations they pointed out?
Well, one of the main ones is just the lack of comparable studies. They specifically mentioned a study from Harvard Medical School that showed some similar changes in the cortisol signaling pathway in COVID patients. But there's just not a lot out there to compare it to.
Right. So it's kind of hard to say with certainty how much these findings apply to the broader population of COVID-19 patients.
Exactly. We need more research, larger studies, more diverse patient groups are needed to really confirm these findings and see if they hold true across different populations.
And of course, there's always those confounding factors to consider, like, pre-existing health conditions, medications, age, lifestyle, all that.
Oh, absolutely. All of those things can influence how COVID affects the body, including the endocrine system.
So while this study offers some valuable insights, we need to be a little cautious about jumping to any, definitive conclusions just yet.
I agree. It's a piece of the puzzle, but we need more pieces to get the full picture.
Yeah, that makes sense. But even with those limitations in mind, this research is still incredibly valuable, wouldn't you say?
Absolutely. It opens up this whole new avenue of investigation into the long-term health effects of COVID, and it highlights the importance of taking a more holistic approach to healthcare, really considering the interconnectedness of different systems in the body.
I'm really starting to see how this research could actually change the way we think about treating patients post-COVID.
Absolutely. We can't just focus on treating the respiratory symptoms and call it a day, right? Mm. We have to be mindful of the potential impacts on other systems, like the endocrine system.
Right. So it's not just about, getting over the cough or the shortness of breath. It's about addressing the whole body.
Exactly. And that's where personalized medicine comes in.
Personalized medicine. What do you mean by that?
Well, tailoring treatments and management strategies to the individual patient, really taking into account their unique genetic makeup, their medical history, their lifestyle factors, all of that.
So instead of this one-size-fits-all approach to treatment, we need to be more precise and targeted in how we care for people who've had COVID.
That's exactly right. And understanding the role of endocrine dysregulation in COVID is a really crucial step in that direction.
This whole conversation has really shifted my perspective on COVID-19. I used to think of it as primarily a respiratory illness, but now I see that it can have these far-reaching effects on multiple systems in the body.
It's amazing, isn't it? That's the beauty of research. It helps us expand our understanding and challenge our assumptions.
And speaking of challenging assumptions, this study really makes you wonder about the potential long-term consequences of even mild cases of COVID. I think a lot of people assume that if they had a mild case, they're totally in the clear. But maybe that's not the whole story.
Right. That's a really common misconception, I think. We tend to focus on the severe cases, but as this research suggests, even mild cases can trigger these underlying changes in growth factor signaling, and endocrine function.
So just because someone had a mild case doesn't mean they're completely out of the woods?
Exactly. Long COVID is a real thing, and we're just starting to, understand how big of a deal it is.
Yeah. It's a little bit unsettling, to be honest. This research suggests that endocrine dysregulation might be a key factor in long COVID.
It's a definite possibility that we need to investigate further, for sure.
This is all quite a bit to take in. It makes you wonder what this all means for people who've had COVID. Even if they had a relatively mild case, what should they be aware of?
I think the most important takeaway is awareness. If you've had COVID, even a mild case, just pay attention to your overall health. Be mindful. Seek medical attention if you notice any unusual symptoms, any changes that concern you.
That's good advice, but what kind of symptoms should people be on the lookout for? What are some red flags?
Well, that's a great question. And honestly, it's something healthcare providers are still trying to figure out. But some potential symptoms of endocrine dysregulation could include things like fatigue, unexplained weight gain or weight loss, changes in mood, difficulty sleeping, irregular menstrual cycles. Those are just a few examples.
So it's not always easy to pinpoint, I guess.
Right. It can be subtle sometimes.
Yeah. Okay, so if you experience any of those symptoms after having COVID, it's worth talking to your doctor.
Absolutely. Always better to err on the side of caution and get things checked out. Don't ignore those signals your body is sending you.
Yeah, that's good advice. We've talked a lot about the potential negative consequences of endocrine dysregulation in COVID, but I'm curious, could there be any potential benefits to these hormonal changes?
That's an interesting thought.
Right. What if in some cases these hormonal shifts actually help the body fight off the virus or mitigate some of the damage it causes? I mean, it's a bit of a crazy idea, but...
I see what you're saying. It's true that hormones play this really complex and often paradoxical role in the immune response.
Right.
So, for example, cortisol, while often associated with stress and immunosuppression, it can also have anti-inflammatory effects in certain situations.
Exactly. And what about those growth factors we were discussing earlier? Could their increased activity actually be promoting tissue repair and regeneration in some cases?
That's certainly possible. Growth factors are essential for wound healing and tissue regeneration, so their upregulation in COVID-19 could be, a double-edged sword. On one hand, maybe contributing to endocrine resistance. On the other hand, maybe promoting healing.
It's like our bodies are walking this tightrope, trying to balance the need to fight off the virus with the need to repair the damage.
That's a really good way to put it. It really underscores the incredible complexity of the human body.
Yeah.
And its response to these challenges, like viral infections.
This is why I love talking about science, It's just so fascinating, full of surprises, constantly challenging our assumptions.
Me too. This research is a perfect example of that. It's opened our eyes to this whole new dimension of COVID-19, and it's given us a lot to think about, a lot to explore further.
Well, I think we've covered the key points of this research article in pretty good detail.
I agree. We've explored the potential link between COVID-19 and endocrine dysregulation, delved into the possible role of growth factor signaling. We've discussed the implications of these findings for both patients and healthcare providers.
And we even zoomed in on those intriguing roles of MMP9 and pseudo-Cushing syndrome.
Yeah, we've covered a lot of ground.
We have. But before we wrap up this deep dive, I want to take a step back and consider the broader implications of these findings. If we zoom out a bit, what are the key takeaways here? What does this research tell us about COVID-19 and its potential long-term effects?
Well, I think one of the most important takeaways is that COVID-19 is not just a respiratory illness.
Right.
It's not just about the lungs. It can have these really far-reaching effects on multiple systems in the body, including the endocrine system. We have to think bigger.
Yeah. We tend to focus on that immediate threat of the virus, but this research really underscores the need to be mindful of the potential for long-term complications.
Absolutely. And it highlights the need for a more holistic approach to healthcare, one that considers the interconnectedness of all the different systems in the body.
Right. We can't just treat the lungs and consider the job done. We need to be thinking about the potential impact on the heart, the brain, the endocrine system, the whole shebang.
Exactly. Another key takeaway is that even mild cases of COVID-19 can have long-term consequences.
Yeah, that's a bit of a scary thought. Just because someone didn't end up in the hospital doesn't mean they're completely in the clear.
That's right. Long COVID is real, and we're really just beginning to understand its full scope.
And this research suggests that endocrine dysregulation might be a key factor in that whole long COVID phenomenon.
It's certainly a possibility that warrants further investigation.
So where do we go from here? What are the next steps in terms of research and understanding these long-term impacts of COVID-19 on the endocrine system?
Well, there's a lot of ground to cover. I mean, researchers really need to delve deeper into the mechanisms that are driving these hormonal changes. We need more studies, especially those longitudinal studies that follow patients over time,
Hmm.
track the long-term effects of COVID on hormone levels, endocrine function, all that.
Yeah, those longitudinal studies, those are crucial for understanding the trajectory of these changes and identifying potential risk factors for long-term complications.
Absolutely. And we also need to investigate potential treatments for this endocrine dysregulation in COVID patients. Can we develop therapies that actually address these hormonal imbalances? Can we prevent or mitigate long-term health problems? These are all really important questions.
Those are huge questions. I mean, this research has really, opened a can of worms, revealing a whole new dimension to the COVID-19 pandemic.
It has. It definitely has. And while it's raised some concerns, it's also sparked all these new avenues of research and the potential for developing more targeted and effective treatments for those suffering from long COVID. It's an exciting time in a way.
It is. It is. Well, on that note, I think we've covered a lot of ground in this second part of our deep dive. We've discussed the study's limitations, the need for further research, and the broader implications of these findings for both patients and healthcare providers. Join us for part three, where we'll wrap up our exploration of this fascinating research. We'll be revisiting that crucial connection between GNS and cortisol signaling, exploring the intricacies of those potential pathways in more detail. And we'll also be pondering a bit of a provocative question. Could there be any hidden benefits to these hormonal changes triggered by COVID-19? Stay tuned for the final part of our deep dive, where we'll try to unravel these mysteries and leave you with some food for thought. Okay, so we're back for the final part of our deep dive into this fascinating COVID-19 endocrine research.
I got it.
It's been quite a journey, you know? Before we wrap things up, I want to go back to one of the most complex things we talked about, that connection between the GNS protein and cortisol signaling.
Yeah, definitely a head scratcher.
I'm still trying to wrap my brain around all the potential pathways.
I hear you. It's a lot.
It is, it is.
But hey, maybe we can unpack it a little bit more, make it a little clearer.
I hope so, I hope so.
If you remember, the researchers proposed those three main ways that GNS might be interacting with cortisol signaling. Through angiotensin, through those CRF molecules, and then by influencing the production or processing of PMOC, which is the precursor to ACTH.
Right, those three pathways. And I got to be honest, each one had me feeling like I needed to go back to school and get a degree in biochemistry or something.
Well, hopefully we can make it a little easier to understand.
Fingers crossed.
So remember, angiotensin is a hormone that plays a role in regulating blood pressure and fluid balance.
Yeah, and it's also part of that REAS pathway.
Exactly, the renin-angiotensin-aldosterone system. And what's interesting is that GNS is known to bind to angiotensin.
Okay, so could that binding be how GNS is indirectly affecting that RAS pathway and then ultimately impacting those cortisol levels?
That's one of the hypotheses that the researchers put forward, yeah.
Okay, so it's kind of like a domino effect. GNAS binds to angiotensin, which then influences the RAAS pathway, and then all of that could be contributing to the dysregulation of cortisol.
Yeah, that's the idea.
All right, I think I'm following so far.
Good.
Now, what about those CREB molecules? Those were the transcription factors, right?
Yep, they control gene expression.
Right, so if I remember correctly, GNAS can activate a signaling pathway that leads to the production of a molecule called CAMP, and that CAMP then activates CI.
That's exactly right.
So it's like this chain of command. GNAS gives the order, CAMP carries the message, and then CAB flips the switch on certain genes. And potentially that influences cortisol signaling.
Exactly.
It's a lot of moving parts.
It really is, yeah.
And then there's that third pathway, right, where GNS might be influencing the production or the processing of PMOC. And that's the precursor to ACTH, the hormone that normally triggers cortisol release.
Right. So if GNS is messing with PMOC, it could be affecting how much ACTH is produced, and that would directly impact those cortisol levels.
Okay, so we've got these three potential pathways. GNS interacting with angiotensin, GNS messing with CAB, and GNS influencing PMOC. And all of them could potentially be impacting cortisol signaling in COVID-19 patients.
That seems that way, yeah.
This is a lot, but I think I'm starting to get a better handle on those potential pathways.
Yeah.
Even if it's still a bit mind-boggling. But, we've talked so much about the negative consequences of endocrine dysregulation in COVID-19, and I can't help but wonder if there's another side to this. Could there be any benefits?
Benefits?
Yeah, I know it sounds counterintuitive.
It does, yeah.
What if in some cases those hormonal shifts are actually helping the body fight off the virus, or maybe reducing some of the damage?
You're thinking outside the box. I like it.
I'm trying to stay optimistic.
Well, hormones do often play this kind of dual role in the body.
Right.
And the immune response is no exception to that.
That's what I was thinking. So, for example, cortisol. We always think of it as this big, bad stress hormone that suppresses the immune system. But sometimes it can also have anti-inflammatory effects, right?
That's true, it can.
And what about those growth factors we were discussing, their increased activity? Could that possibly be promoting tissue repair and regeneration in some cases?
That's actually possible. Those growth factors are absolutely essential for wound healing and tissue regeneration. So their upregulation in COVID-19, it could be a double-edged sword, contributing to endocrine resistance, but maybe also promoting healing.
It's like our bodies are constantly trying to find that balance, right?
Yeah, it's like this constant push and pull.
Trying to fight off the virus, but also repair the damage that it causes.
Exactly. And I think it really highlights the complexity of the human body and how it responds to challenges like viral infections.
This is why I love science. It's full of surprises. There are always more questions than answers.
Oh, yeah, absolutely. And, this research is just the tip of the iceberg when it comes to understanding those long-term consequences of COVID-19 and its impact on the endocrine system.
Well, I think we've done a really good job of breaking down this research. I think we hit all the key points.
I agree. We talked about the potential link between COVID-19 and endocrine dysregulation, the role of growth factor signaling. We even looked at MMP9 and pseudo-Cushing syndrome.
We covered a lot of ground. From those potential GNS pathways all the way to the possibility that these hormonal changes might actually have a silver lining.
It's been a fascinating discussion.
It really has.
I hope our listeners found it helpful and maybe learned a thing or two.
I second that. To our amazing listeners, thank you for sticking with us on this deep dive into the world of hormones and how they interact with COVID-19. I hope this episode has given you some new insights and sparked your curiosity to learn even more. Remember, this is just one piece of the puzzle, and as research continues, we'll definitely get a clearer picture of the long-term effects of this virus and how to best manage them. Until next time, stay curious, stay informed, and stay well.
Thanks for listening today. 4 recurring narratives underlie every episode: boundary dissolution, adaptive complexity, embodied knowledge, and quantum-like uncertainty. These aren't just philosophical musings, but frameworks for understanding our modern world. We hope you continue exploring our other podcasts, responding to the content, and checking out our related articles at helioxpodcast.substack.com.